Hi there! Welcome to the 50th episode of the Synth project, where we are building a synth together. Given that our synth rack is getting full of new elements, many of which are capable of generating sounds of their own, it is time to think of something that will be able to put all these sounds together, allowing to individually adjust the level of each signal and generating a sort of stereo sound, balancing the various sounds over the two classic stereo channels. In other words, we need to think of an audio mixer with panning capabilities. Since the mixer module will be substantially complex, we will divide the description, design and execution into several parts, which will culminate in the completed new module working and installed in the synth rack. In the last episode, I will also offer a long and detailed demo of its functionalities, along with examples of how to patch the synth to obtain specific features. Today's episode is dedicated to the part 1 of this series, the presentation of the block diagram of the audio mixer. Let's begin. The block diagram of our audio mixer is made out of 6 different elements. The view meter, which will be used to detect whether the output audio level is acceptable or too high, which would cause a distortion of the signal. There are going to be 2 view meters in this module to accommodate both the left and the right channel, and they will help us regulate the level of the overall signal for that channel. Another element of the mixer will be the adder, which is the element that will actually pull together all the signals of the same channel, left or right, and add them together to obtain a mix of all the generated sounds. So we will have 2 of such elements, the left one and the right one, each attending at the mixing of all the signals for that specific channel. Next element is the headphone amplifier. Although the output signal level can go up to a peak of ±10 volt, it does not have enough power to drive the transducers of a headphone. And so we will need a stereo headphone amplifier that will take the stereo output and amplify its power so to be able to drive an externally attached headphone. Next element is the panning stage, used to split the input of each signal in order to provide the capability of adjusting the level ratio between the left and the right channels for an effective stereo sound capability. The audio mixer will have 8 separate inputs, each with its own panning stage, and therefore we will have a total of 8 panning devices, all equal to each other. The last 2 elements are the input stage, used to insert a specific signal into the mixer and to adjust its level independently from the other inputs. As we said already, we will have 8 separated input stages. However, 6 of them will be standard inputs capable of handling 10 volt peak signals, and this is the first kind of input device. The remaining 2 input stages, the second kind, will have a much greater sensitivity and will be able to amplify the very small signal from a magnetodynamic device, like a dynamic microphone, for example, or an electric guitar pickup. All these elements will make the bigger mixer module that I will install in the upper shelf of the synth, and will occupy a generous quarter of the whole space of it. I know it's a lot of space, but it will be worth to have it. I am already planning to use it to connect the synth to the audio system of my family room, a Yamaha 700 watt 6 channels power audio amplifier. Additionally, for this module, I plan to put all the circuitry on a number of separated PCBs, which I will make by myself rather than have them made by my usual PCB maker and supplier. We will talk more about this in other episodes of this mini-series. And with that, I will call it for the day, leaving you with my usual happy experiments.